Okay, we're going to go through the first few problems from your 5.2 assignment. And in the first section here for numbers our problem is 2, 4, 6, it's going to say state whether or not the function satisfies the hypothesis of the mean value theorem. Well, here's our mean value theorem here. It says if the function is continuous, pencil never lifts from the paper as we draw it at every point of the closed interval from A to B, and it's differentiable at every point in that interior. In other words, we find the derivative, we look for points of non-differentiability. We look for when denominators are 0 or square root issues with negatives. Then there's at least one point in there, and we'll call it C, a value of x equals C from the interval where the derivative at C is equal to the slope of the entire secant curve, or excuse me, it's the secant line from the beginning of the interval to the end of the interval. So when the question states this, state whether or not the function satisfies the hypothesis, we'll do that, and then it says if it does, find each value of C in the interval that satisfies the equation. Best case scenario for us work-wise would be that mean value theorem, the hypothesis is not satisfied. So we can expect it probably will be most of the time, but perhaps not on occasion. So first off, does it satisfy the mean value theorem? Well, from 0 to 1, is this function continuous? Yeah, I can put 0 in here. I can square any number I want. I can take the third root of any number I want. No problem. So the next step would be, well, let's find out about its derivative. The derivative would be 2/3 x to the negative 1/3, or 2 on 3 third root, or x to the 1/3, third root of x, or x to the 1/3 is our derivative. And now we realize, hey, I can take the third root of any number I want, but I can't divide by 0, so perhaps I have some issues. Let's take a look at this and read it real carefully now, because 0 is an issue, but 0 is also an endpoint, so we have to interpret this correctly. If y equals f of x is continuous at every point, well, the function is continuous from 0 to 1 and differentiable at every point of its interior. So that would exclude that value of 0. Therefore, anything bigger than 0 here is going to be fine. So this barely satisfies the mean value theorem hypothesis. And so at that point, it says, well, let's find out where the slopes are equal. So I want to find if f prime of x equals this, then f prime of some value c, where x is any value c is a specific point. It's going to look the same though. I want to find where that is equal to our slope as the x values go from 0 to 1. So I need to find f of 0, and that is clearly 0, and I need to find f of 1, and they're making it easy on us here for starters. That is clearly 1, and now I need to find the slope from the point 0, 0 to the point 1, 1. So that slope is very easily y value minus y value. That would be 1 minus 0 over 1 minus 0, or 1. So I want to find when these guys are equal. So therefore, 2 on 3 times third root, if you like, of c is supposed to equal 1. If I cross multiply, I get, let's see, I'm going to put that over here. I don't have much room left there. I'm going to put that over here. I get 3 times the third root of c equals cross multiply 2, or third root of c equals 2/3, or c equals 2/3 to the third, and that is 8/27. And that would be our value of c. We just have to make certain it is on that interval Well, it is on the interval from 0 to 1. Now imagine we might get multiple solutions for this at some point, and if there's multiple solutions, there's a good chance that one of those doesn't fit in here. If none of the values fit in there, we better go back and check our work or reevaluate whether the mean value theorem applies. Because the rule says somewhere in there our slope is going to have to be equal to 1, because the slope of the secant, where this curve starts to where it ends on that, is 1. Okay, now how about this guy? Is this continuous from 0 to 4? Yeah, absolute value functions, I never have to lift my pencil. However, is it differentiable at all the points from 0 to 4? We should note that the graph of this guy, shifted to the right one, wants to look like this from 0 to 4. And it is not differentiable because we have a corner point at 1. So, does not meet the mean value theorem hypothesis. Yay, let's move on. Okay, number 6. I think I have a sheet for number 6 here. Number 6. F of x equals ln x minus 3. Now, ln x minus 3 has some problems. It's not continuous everywhere. There's issues around 1, because I can't take ln of 0. But I can take ln of 2 through 4. So it meets, it is certainly continuous. Let's see if it is differentiable everywhere. F prime of x, the derivative of ln x minus 1, is 1 on x minus 1 times the derivative of x minus 1, but that's just 1. This is not differentiable at 1. However, it is differentiable from 2 to 4. I can put values from 2 to 4 in there. So the mean value theorem hypothesis is met, and we got some more work to do. Okay, so let's find this one out. I need to find f of 2. That is ln of 2 minus 1, or ln of 1. And ln of 1 is the exponent that turns e into 1. That is 0. So I have an ordered pair. My starting ordered pair is 2, 0. Let's find f of 4. Not as convenient. That is ln of 4 minus 1, or ln of 3 for the ordered pair 4, ln 3. Okay, and there must be, because of the mean value theorem, there must be a point where f prime of c, which of course is 1 on c minus 1, equals this. So I'm going to go 1 on c minus 1 needs to equal the slope of these, I should say. So that's y minus y. Our slope over here is y minus y, ln 3 minus 0 on x minus x, 4 minus 2. So this is ln 3 on 2. Little cross multiplying. In fact, I'm just going to flip both fractions. I'm going to get c minus 1 should equal 2 on ln 3, or c equals 2 on ln 3 minus 1. So if we want that as a plus 1, excuse me, plus 1. If we want that as an approximation, let's go 2 divided by ln 3 plus 1. That is 2.820. We double check and confirm. Yep, sure enough, it's in that interval. You need to check that. If it's out of that interval, we've made a mistake, or the hypothesis perhaps was not met. So C is either 2 ln 3 plus 1 exactly, or approximately 2.820. 820. Okay, so not too bad for the first set. Stay tuned. We'll be looking at this in a series of videos for this homework set.